Good morning, everybody. Now, this lecture that I'm recording is for spectroscopy. But just for your information, let me tell you that spectroscopy chapter was already started in the class and it was almost done. A very small topic was left to discuss. I guess so. The selection rules were left to discuss. While I was teaching this in EXCCA, my voice was okay and it was good. But then I realized that when I taught actually in the ECB division, that day I was touching myself actually, and my voice actually got um after that it went very bad. So basically, क्या है, that day I was trying to teach, and students were also being very kind and patient, and they were trying to pay attention to what I'm saying. But I believe in that, because of the voice problem, I don't know how much they were able to understand. They were just being kind, but that is the reason why I decided that I will also record this lecture. Okay, the beginning part, everything is already done, but yet I will, like, I can't just record the last part, right? I will have to record the entire chapter. That is why I'm going to start from the beginning. But that does not mean that this was not started in the class. Okay, chalo. So now let's start. Okay. So in the first slide, I've written the contents, but do not worry that these are you might think that, oh my God, so many topics we will learn, but these are all very very small concepts that we have to understand. Okay. Now, what is spectroscopy? Spectroscopy is basically, if you remember, I told you, it is just basically how light interacts with matter. You people have already studied. You have background of physics. You know that light interacts with matter. Okay, every color that we observe has some meaning behind it, right? Now, actually, if you have to understand the technique or technology spectroscopy, you need to have a little background of electromagnetic spectrum. Now, electromagnetic spectrum क्या है, and then वो कैसे spectroscopy से related है, that we can understand. Okay, so let's go ahead and try and understand. Basically, this is also done. So this is just brushing up your basics. Actually, this is nothing anything. This is nothing new that we are going to discuss. Okay, electromagnetic spectrum is basically whatever radiation or energy that we receive from sun. The speed of this light, the radiation is 3 into 10 raised to power 8 meter per second. That also, if you have to calculate the energy possessed or carried by these radiation, the equation that you're going to use is E is equal to C into E is equal to H into nu, which is the frequency. But frequency you can substitute as C upon lambda, speed of light upon the wavelength of the radiation. Correct. So this, with this basic understanding, in the next slide, I basically have some GIF, which just represents that with the name electromagnetic spectrum. Why? Because it has two components: electric waves plus magnetic component is also there. Light has dual nature, particle and the wave nature. Correct. So wave nature is basically responsible, or in the spectroscopy technique, not the particle behavior. Okay, तो वेव एंड पार्टिकल में से जो वेव नेचर है is playing important role in the spectroscopy concept. Now, yes, we are here to understand the electromagnetic spectrum. Now, this entire electromagnetic spectrum, okay, which is nothing but light, is basically divided into certain regions. Now, these regions, the names are in very well in front of you: gamma rays, X rays, ultraviolet, UV, visible, then IR, microwave, then radio. Correct. Now, while we move from gamma to radio waves, you can understand, नीचे भी देखो जो वो wavelength की तरह दिया है ना, from that you will understand gamma rays have the shortest wavelength. Okay, whereas the radio waves have the longest wavelength. Okay, now as wavelength and frequency are inversely proportional, what about the frequency of gamma rays? Highest frequency. And frequency of radio waves, lowest frequency. And if you go back to this equation, E is equal to energy is equal to H into frequency. So basically, energy is directly proportional to frequency and inversely proportional to wavelength. So gamma rays have the highest frequency. So energy, एक minute. So energy possessed by gamma rays would be the highest, whereas energy possessed by the radio waves would be the lowest. And then you can understand the sequence की x-rays के energy क्या होंगे, कम होंगे gamma rays से, but एक्सरे का एनर्जी क्या होगा, ज्यादा होगा अल्ट्रावायलेट रेडिएशन से। अल्ट्रावायलेट रेडिएशन का एनर्जी ज्यादा रहेगा विजिबल से, विजिबल का एनर्जी ज्यादा रहेगा IR से, like that. Okay, so this is the arrangement, or these are the various regions of radiations in the electromagnetic spectrum. Now, basically, what about that? Okay, how is it related to the molecules, to the spectroscopy? Now, basically, who invented spectroscopy? Isaac Newton, the great scientist. Now, what did he notice? How did he come up with this concept? I will tell you. ये जो आपने सारे प्रीवियस इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम में अलग अलग रीजन दिखे, अलग अलग रीजन का अलग अलग फ्रीक्वेंसी जोन है, वेवलेंथ जोन है, मतलब अलग अलग एनर्जीज दे possess. Now each of these energy, they are actually comparable or identical, you can say, with molecular energies. Every molecule has basic certain energies. तो ये जो energies रेडिएशन के हैं वो अपने मॉलिक्यूल के एनर्जीज से मैप्ड होते हैं। तो ये कौन से मॉलिक्यूल के एनर्जीज है? There are electronic energy levels, there are vibrational energy levels, rotational energy levels. So these energies, when the electron has to undergo transition from, let's say in between electronic levels या फिर vibrational levels, तो उनको कुछ एनर्जी लगेगा। तो वो एनर्जी कितना लगेगा, वो क्वांटाइज्ड है। हाउ क्वांटाइज्ड? बिकॉज एनर्जी लेवल्स आर मैप्ड। तो वो क्वांटाइज्ड एनर्जी किससे मैप होते हैं? एनर्जी इज पॉसेस्ड बाय रेडिएशंस इन द इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम। सो व्हाट डिड आइजैक न्यूटन थॉट अबाउट कि अरे इलेक्ट्रोमैग्नेटिक स्पेक्ट्रम है, उसमें अलग अलग रीजन्स है, उनके डेफिनेट अमाउंट ऑफ एनर्जीज दे possess. Now these energies are exactly mapped with the energies possessed by molecules, correct? तो उन्होंने सोचा, why not develop a technology? Now this technology that he thought about is, why it is so important. It is important because it has certain advantages over the classical method, जो already existing methods थी उनसे ज्यादा बेनिफिट्स थे स्पेक्ट्रोस्कोपिक टेक्निक के। सो आई विल टॉक अबाउट दैट लिटिल लेटर, बट इफ यू हैव चेक्ड द एमएससी सैम्पल पेपर, तो मैंने ये उसमें सम्स डाले हुए हैं। ओके, ये आई थिंक सो 2 मार्क्स का है या 3 मार्क्स, 3 मार्क्स, देयर इज नथिंग 3 मार्क्स। 2 मार्क्स का क्वेश्चन आई हैव एडेड न्यूमेरिकल प्रॉब्लम, एनर्जी यू हैव टू फाइंड आउट। So practice these numericals. One was taken, I think so, in the class. It is very simple. Okay, energy of radiation is asked depending upon the wavelength. The wavelength is given. The only thing is you have to be very careful about the unit of the wavelength. Wavelength, if it is given in Armstrong or nanometer, you will have to convert that first in the meter. Okay, appropriate conversion rules you use: if it is nanometer, multiply by 10 raised to minus 9. Okay, if it is an Armstrong, then you will have to convert, you will use 10 raised to minus 10 मीटर। ओके, वैसे। और फिर आपको आंसर मिलेगा जूल्स में। वैल्यू ऑफ प्लैंक्स कांस्टेंट एंड स्पीड ऑफ लाइट इज ऑलरेडी मेंशन इन द क्वेश्चन पेपर। ओके, सो डू नॉट वरी अबाउट दैट, डू नॉट रिमेंबर दोज वैल्यूज। ठीक है, चलो। तो अभी तक मैंने क्या बताया आपको? What is electromagnetic spectrum? There are various regions. Each region basically has certain amount of energy, and those energies are exactly comparable with the energies of the molecule. And then these sums you are supposed to solve. Now, what is this relation? Like how electromagnetic spectrum is related to spectroscopy? Why are we even discussing electromagnetic spectrum? So basically, this electromagnetic energy के जो electromagnetic spectrum के जो मैं energies बोल रही थी, तो वो कौन से वाले comparable है? So basically, 3 molecular energies. If you pass microwave region, microwave radiation, I mean, microwave radiations from electromagnetic spectrum, मॉलिक्यूल में कहाँ पे चेंजेस होंगे? रोटेशनल एनर्जी लेवल्स में चेंजेस होंगे। whereas if you pass infrared radiation, then changes in the vibrational energy levels will take place. Next, if you pass UV visible, both these regions together, if you use these regions together on the molecule, अगर आप वो लाइट डाल रहे हो मॉलिक्यूल पे, तो मॉलिक्यूल में चेंजेस होंगे in the electronic levels. Okay, for the moment, just try to remember microwave region, rotational energy. IR region, vibrational energy, and UV visible region, electronic energy. Now I will take you to one slide which is a little ahead. Okay, 1 minute. Huh? Okay, observe this image. Now there are certain electronic levels. Each electronic level, if you observe, is divided into certain vibrational levels, and then each vibrational level is divided into rotational energy levels. Okay, now observe the difference between two electronic levels. It is the highest, correct? Do you agree? Then, followed by this, observe distance between two vibration energy levels. It is less than that of electronic levels, correct? But it is more than that between two रोटेशनल लेवल सो रोटेशनल लेवल्स में दो रोटेशनल लेवल्स के बीच में जो डिस्टेंस है वो सबसे कम है द लीस्ट एनर्जी डिफरेंस इज बिटवीन टू रोटेशनल एनर्जी लेवल्स एंड द हाईएस्ट एनर्जी डिफरेंस इज बिटवीन टू इलेक्ट्रॉनिक एनर्जी लेवल्स तो अगर आप चाहते हैं कि इलेक्ट्रॉनिक एनर्जी लेवल्स में चेंज हो तो आपको कौन सा तो आपको हाईएस्ट एनर्जी वाला रेडिएशन पास करना पड़ेगा अगर आपको वाइब्रेशन एनर्जी लेवल में चाहिए तो उससे थोड़ा कम एंड अगर आपको चेंजेस चाहिए रोटेशनल एनर्जी लेवल में तो आपको उससे भी ज्यादा उससे भी थोड़ा कम एनर्जी वाला रेडिएशन पास करना पड़ेगा नाउ व्हाट वाज द एनर्जी लेवल्स आई सेड बिफोर फ्यू स्लाइड्स माइक्रोवेव रीजन रोटेशनल IR region vibrational and UV visible region अपना electronic now I will go back to the electromagnetic spectrum तो अभी ऑब्जर्व करो electromagnetic अभी ऑब्जर्व करो the spectrum observe the position of UV visible position of IR and position of microwave region okay which region do you think possesses the highest energy amongst these three you consider UV visible as one okay for the moment so out of these three which one possesses the highest energy UV visible isn't it because it has the shorter shortest wavelength in these three comparative to the other two. Microwave has the longest wavelength as compared in these comparison of these three. तो microwave का energy होगा सबसे कम. That is why if you incident microwave region changes in the vibrational. If you incident IR changes in the vibrational. If you incident UV visible changes in the electronic. So rotational, vibrational, and electronic. So now do you understand how smart Sir Isaac Newton was? Obviously, everybody knows he was very, very intelligent. But again, he thoughtfully designed this and he came to the conclusion कि अरे electromagnetic region के energies directly molecules से map होते हैं. Most of the molecules के energy से map होते हैं. So why not use it? Okay. And you know what happens, students, every molecule has a unique identity. तो basically ये जो technology है, which is spectroscopy technology, it is very, very powerful. It can be used for two different kinds of analysis. Number one, you know, think about that example I gave you in the class. Suppose you are working in the forensics team and you are analyzing some crime scene. तो आपको कुछ samples collect करना है आपको कुछ samples मिले some chemicals you collected that and then the thing is first and foremost question is what is that chemical correct so in order to find out what is the chemical that is called as qualitative analysis what is present checking what is present तो वो टेस्ट करने के लिए भी आप स्पेक्ट्रोस्कोपी यूज कर सकते हो apart from that once you understood what is the chemical next question would be what is the concentration what is the amount of that chemical that is called as quantitative analysis for that also spectroscopy is useful okay there are very few technologies techniques that are there which can be used for both these kinds of analysis qualitative both qualitative and quantitative this is one such powerful technique जो आपको बताएगी कि क्या present है और कितना present है okay now, these are certain advantages of spectroscopy. You know, you have performed one qualitative test in your, I think, so junior college level, flame test. तो आपको टीचर कंपाउंड देती थी एंड देन यू आर सपोज टू होल्ड इट इन दैट लूप कॉपर लूप होता था and then that copper loop compound in the copper loop you are supposed to hold in the flame. Then from the color that it emits, basically again that is color emission, right? Color that you observe, you have to write down what is the element present वैसे. तो वहां पे क्या होता था, your sample gets destructed. Now if you are working in the forensics, you have collected some sample, that sample might be very less amount of sample. You cannot afford losing that sample. You are supposed to preserve those samples for many a very long period of time, maybe till the trial of the case is there or something like that. So you can't afford destruction of the sample, right? You can't hold it in the flame. Instead you can use spectroscopic technique. आपको बस वो सैंपल लाइट सोर्स के सामने रखना है, लाइट विल पास थ्रू इट एंड यू विल गेट योर आंसर्स, यू विल गेट योर रिजल्ट्स इन द फॉर्म ऑफ द ग्राफ और स्पेक्ट्रम. तो आपका सैंपल भी प्रिजर्व हो जाएगा, बहुत कम अमाउंट ऑफ सैंपल लगेगा. स्पेक्ट्रोस्कोपिक स्पेक्ट्रोफोटोमीटर्स आर वेरी कॉस्टली बाय द वे. Let me tell you, they are extremely costly, but in a long run they become cost effective. मतलब एक बार परचेज कर ले तो बाद में पैसा वसूल है, that is the logic, right? So in long run it becomes cost effective, obviously. Okay, so there are many advantages of this technology. Understood? The results that you get are reliable. You can't be as a तळ्यात मळ्यात नाही आहे. You get short results, correct? So it is a very powerful technique. So many advantages. This is a very important slide according to me. First and foremost, understanding why this technique is so great. Okay, now moving ahead. Sorry. चलो ना, नेक्स्ट आई हैव इंक्लूडेड प्रिंसिपल ऑफ स्पेक्ट्रोस्कोपी. प्रिंसिपल ऑफ स्पेक्ट्रोस्कोपी क्या है, वही मैंने बोला, हाउ लाइट इंटरेक्ट्स विद मैटर. So you have a molecule, you need to find out its identity, pass light through it. Okay, light will do its work, the electron will undergo transitions, and then while you're learning, while you're capturing those transitions, you get information about that molecule. तो अभी आपको तो मैं वैसे बता रही हूँ, what we used to do was a very like actual detailed study. I'm just telling you what basically happens. Now in the molecule there are energy levels, ground state, excited state. So when you pass the light, when you are exposing a chemical to the light source, basically the electrons are going to undergo transitions from ground state to excited state. It will stay in the excited state for some time and then it will again fall back into the ground state. So basically, um, based on this logic that it is going to absorb the light and also it is going to emit the light, there are two types of spectroscopy, two basic types, absorption and emission. तो इसमें हो क्या रहा है एक्चुअली, अगर आपका स्पेक्ट्रोफोटोमीटर, अगर आपका डिवाइस, if it is measuring which light is getting absorbed. Now what is the meaning of which light, what is the wavelength of light the molecule is absorbing? If you are capturing that information, then it becomes absorption spectroscopy. But whereas, let's say, molecule has absorbed the light, but then once the electron is in the excited state, it is going to fall back to the ground state. And if your device is measuring which light is getting emitted, तो वो हो गया emission spectroscopy. Okay. So depending upon which light you are measuring, either the one which is getting absorbed or the one that is getting emitted, the spectroscopy is of two types, absorption and the emission. But let me tell you, there are many other types of molecular spectroscopies also. आइजैक न्यूटन ने क्या किया, एक बेसिक आइडिया दिया लोगों को कि देखो भाई, मॉलिक्यूल्स में ऐसे ऐसे एनर्जीज है, अगर आप लाइट उसमें से पास करोगे तो वो बहुत इंटरेस्टिंग फैक्ट्स बताएगा मॉलिक्यूल के बारे में. तो उन्होंने सिर्फ एक बेसिक आइडिया दिया, but later on many scientists worked on it and they developed various spectroscopic techniques. Correct. Now one such spectroscopy is scattering spectroscopy, which was developed by our very own Dr. Sir C.V. Raman. Okay. So in that technology, whatever he developed, in that which light is measured, the light that gets scattered by the molecules. Correct. He did not develop something which wherein absorbed light is measured or emitted light is measured. What light measures? The light that gets scattered. So it is a very interesting. I'm just giving you a brief introduction. Okay. These are very, we have learned it in very much details. उसका physical chemistry, उसका molecule level पे क्या होता है, सब हमने ये किया हुआ है. You people are engineers, so you do not have to study at that molecular level. Okay, you just need to have the basic idea so that you can code. Okay, you can code up for your technology that you can maybe develop. Now, what am I saying? Coding and all. देखो आपको अच्छा ये बात निकली है तो बता ही देती हूँ. Actually, I plan to talk about it towards the end of the lecture. In the previous season of Shark Tank India, there were two ladies who came with one product. Now that their product was a very small, let's say like very small gadget. Now that gadget was something which can be used to detect the freshness of the fruits and vegetables. तो basically क्या करना है, you have to take the fruit and उसमें वो gadget रखना है, उसके ऊपर रखना है, and then it will show you certain readings and you can guess whether the fruit is fresh or it is not so fresh. Then you can decide accordingly whether to purchase or not to purchase. Correct. So agar if you remember, then and if you remember the pitch, then the pitch that she actually explained that the gadget works on the principle of spectroscopy. Correct. Also, there was one group in our two groups actually in our college. They were working for Smart India Hackathon competition. Their problem statement was design a technology which can be used to detect the amount of pesticide used on that vegetable while it was getting cultivated. तो वो pesticide use करने के लिए also students developed a technology which worked on spectroscopy. Okay, तो spectroscopy is a chemical thing, right? Chemistry में है वो. But you engineer, why it is ever engineers, by the way? Because you can use it in the gadgets, right? I was talking to one group which was working on I think so food adulteration. गार्गी वाला group था वो. तो उसमें मैंने बोला था उनको कि सपोज यू हैव टू डिजाइन अ gadget which works or which detects, let's say for instance adulteration in the milk. So you can use spectroscopy in that. So if in the milk a particular chemical is added as an adulterant, that chemical will have some absorption of light, right? So spectroscopy से आप उसमें कोड करके वो गैजेट बना सकते हो. ओके, वैसे मतलब एक सेंसर बेस्ड भी बन सकता है. आई एम नॉट सेइंग सेंसर बेस्ड नहीं बन सकता, एंड स्पेक्ट्रोस्कोपी यूज करके भी बन सकता है. सो दैट्स व्हाई. ओके, चलो, दिस इज हाउ chemical technologies can be used in your products and gadgets. Okay, now moving ahead. Okay, now this slide talks about those various molecular energies: rotational, vibrational, and electronic. Okay, so every molecule will have these basic energies. Oh, you can read about it. This graph I've already explained. Now, next is the types of molecular energies. Okay, now इसमें क्या है? Basically, I said कि rotational, vibrational, and UV Raman spectroscopy. Apart from these, there are many other. यहाँ पे इस टेबल में भी दो है, NMR and ESR. But there is mass spectroscopy. There are many other types of spectroscopies which can be used. Uh, Now, if you refer this table is I think so important from exam point of view also. Like this current exam कि कौन सा स्पेक्ट्रोस्कोपी कौन से रेडिएशन से होता है, कहाँ पे ट्रांजिशन होता है. एंड लास्ट कॉलम का टाइटल है क्राइटेरिया. क्राइटेरिया इज समथिंग व्हाट इज सिलेक्शन रूल. Now, these selection rules, remember students, as specific selection rules कि IR के लिए ये selection rule है, rotational के लिए एक अलग selection rule है. Apart from these selection rules, there are certain general selection rules also. तो हम लोग बात करेंगे उसके बारे में, वो आगे आएंगे. ओके, तो रोटेशनल स्पेक्ट्रोस्कोपी कहाँ पे होता है? अगर आप माइक्रोवेव रीजन use करोगे तो. Correct, because changes in the rotation changes in the rotational energy levels. If you incident IR radiation, then changes in the vibrational energy level. Now I'll ask you a question कि vibrational का अलग नाम vibrational and rotational भी क्यों है? Think about it. It's a very interesting answer. You will find out. You will get the answer. Okay, so you can read and you can understand. What is the specific criteria for rotational spectroscopy? That the molecule must possess a permanent dipole. What is the meaning of that? Molecule which do not have permanent dipole, like hydrogen, okay, oxygen, वैसे तो वो molecules rotational energy spectroscopy नहीं कर सकते. Similarly, vibrational spectroscopy का क्या specific criteria है? That during the molecular vibrations, basically, the dipole should keep changing. The dipole should change. So इसमें क्या है? इसमें molecules like hydrogen, oxygen can also be tested. Why? Because when hydrogen gas is undergoing vibration during some specific vibrations, again I'll not go into detail. Vibrations are also of various different types. So during some of the vibrations, the dipole will change and then it can be tested. वैसे, okay, so this table is important, do read it, and maybe you can learn and go for the exam. Ha, चला. Now this is important, the general selection rules, the basic general selection rules, which are responsible for the spectroscopy. There are three rules actually. अरे हे परत अडकलं एक मिनिट. There are three rules basically. Not going to the next slide. There are three rules, but actually there are only two. Okay, I've written one, and the next page पे जो दो है, they are actually kind of similar. Okay, so let's start understanding these selection rules. Number one selection rule says that when the electron is undergoing transition, उसका जो spin है, it should not change. Okay, so delta S, capital S, the spin multiplicity. I know you know these terms, little bit सिर्फ याददाश्त आनी चाहिए. You should just get those flashbacks. Delta has a spin multiplicity, it should be equal to 0. The spin should not change. Now delta has spin multiplicity का formula क्या है? 2s plus 1. Capital S is equal to 2s plus 1. Now we will try and understand with the help of this image, but कौन से allowed transitions है when a molecule is going from singlet to singlet, allowed, triplet to triplet, allowed. Now what is not allowed, what is forbidden, singlet to triplet or triplet to singlet. Let's try and understand what is the meaning of this. I'm sure you know this. Only thing थोड़ा रिविजन का जरूरत है. ओके, तो ये इमेज में देखो तीन पार्ट्स है. ग्राउंड सिंगलेट स्टेट, एक्साइटेड सिंगलेट एंड एक्साइटेड ट्रिपलेट. तो देखो सिंगलेट का मीनिंग क्या है? ग्राउंड स्टेट में ये जो दो इलेक्ट्रॉन्स है, they are paired, right? One has upward direction, upward arrow, and the other one has a downward arrow. So if you consider the spin of the electron, it is एक का लेट्स कंसिडर प्लस हाफ, दूसरे का है माइनस हाफ. तो टोटल स्पिन कितना हुआ? ऐड करो प्लस हाफ एंड माइनस हाफ को, टोटल स्पिन हुआ 0. करेक्ट. सो इफ यू सब्स्टिट्यूट दिस वैल्यू 0 in the spin multiplicity formula, capital S is equal to 2s plus 1. So 2 into 0 is 0 plus 1. So spin multiplicity becomes 1. So that is why this is ground singlet state. Now when the electron is going into the excited state, the second वाला part में आप देख रहे हो, तो do you observe one electron has upward direction and the other one has downward direction. So total spin again is 0. So hence this is excited singlet state. But what is happening in the picture, third part of this picture? Both the electrons have upward spin orientation. So let's consider plus half spin and plus half spin. Plus half and plus half total कितना हुआ? 1. So 2s plus 1 formula में if you substitute, you will get answer 3. 2 into 1 plus 1, 3. That is why this is excited triplet state. So the meaning is when the electron is undergoing a transition, when it is going to the excited state, the spin of the electron should not change. The spin multiplicity should remain same. So singlet to singlet is allowed, but singlet to triplet will not be allowed because the spin is changing. Okay. Now second rule, second and third is actually symmetry or Laporte selection rule or the angular momentum. I'll first explain angular momentum because then it will be easier for to understand Laporte rule. Okay. Angular momentum is nothing but your angular momentum quantum number. Okay. Angular momentum quantum number of your orbitals, s, p, d, f orbitals. S orbital का angular momentum number क्या है? 0 ना? P का 1, C D का 2 and then 1 2 and F का 3. So the meaning of this rule is when the electron is undergoing transition, the angular momentum should change. And how much should it change? Either by plus 1 value or minus 1 value. Okay, मतलब जब वो इलेक्ट्रॉन ट्रांजिशन करेगा तो एंगुलर मोमेंटम शुड चेंज बाय आइदर +1 or -1. What is the meaning? If let's say in the ground state your electron is in the s orbital, हायर अगर एक्साइटेड स्टेट में अगर वो जा रहा है तो कहाँ पे जा सकता है वो p ऑर्बिटल में जा सकता है, क्योंकि when s to p ट्रांजिशन हो रहा है then there is +1 change in the angular momentum quantum number. It cannot go to s, it cannot go from s to d, हायर d. क्यों? क्योंकि s एंड d में कितना डिफरेंस है? +2 का डिफरेंस है, करेक्ट? सो s to p is only allowed. The next is P to D. Is P to D transition allowed? Yes, allowed, because P का angular momentum quantum number है +1, let's say, and D का है 2. So P to D is allowed. But क्या P to S allowed है? मतलब higher S, obviously. P of the lower level and D of S of the higher level. So that is also allowed, because P to S will be -1. Change in the angular moment number is -1. So, is D2F allowed? Yes, D2F is allowed, and D2P is also allowed, but D2S will not be allowed. Okay, basic. So, meaning क्या है? When the electron is undergoing transition, there has to be change in the angular momentum quantum number, either by +1 or -1. Okay, so certain transitions will be allowed, certain transitions will not be allowed. So D to D transition, D to D, P2P, S2S are not allowed. Okay, this also plays very important role in complex colors shown by the complex. वो 3D series में वगैरह बहुत कुछ है, वो inorganic chemistry में आता है वो सब. And next, now let's try and understand what is Laporte, or that symmetry rule. The symmetry rule is basically when the electron is undergoing transition, it must change the symmetry. Must change the symmetry मतलब अगर आपका इलेक्ट्रॉन s ऑर्बिटल में है, ओके, नाउ अगेन आई विल टॉक इन टर्म्स ऑफ एंगुलर मोमेंटम सिलेक्शन वाला. अगर आपका इलेक्ट्रॉन s ऑर्बिटल में है, तो अगर वो ट्रांजिशन दिखा रहा है तो वो s to s नहीं जा सकता, because s orbital is spherically symmetrical. If it is going to again higher s, then it is again the symmetry will remain spherically symmetrical. So what is the meaning? The orbital should change. मतलब s to p जाएगा, then it is going to the another orbital, which p orbital doesn't have symmetry. So basically, while the electrons are undergoing transition, the symmetry should change, the orbital should change. It can't go from P to P, it can't go from D to D, because when the electron is going from P to P, the symmetry of the electron is not changing. Symmetry of the electron मतलब जिस orbital में हो है वो उस orbital का symmetry is not changing. So that is what I was saying in the beginning, that both these rules are nothing but same. Okay, चलो, तो selection rule. Number one, spin of the electron should not change. Number two, angular momentum quantum number should change either by +1 value or -1 value. And Laporte rule क्या है? The symmetry of the electron, the orbital का symmetry should change. मतलब S to S नहीं जा सकता, because symmetry same है ना S orbital का दोनों का. P to P नहीं जा सकता, तो S to P जा सकता है, P to D जा सकता है, D to P जा सकता है, D to F जा सकता है, वैसे. Okay, got it. Moving ahead, I think so. Applications ka you can read, students, and you can write down not just these. If you want to find out few more applications which you find are easier to remember, you can find on internet, and वो आप 4 से 5 applications याद कर सकते हो एग्जाम के लिए. Okay, now बाद में यहाँ पे क्या है? Apart from this recording, I'm going to give you one more recording, but that was already recorded, like for my students of online batch. So there's one experiment on the virtual lab that we performed during their for their batch. तो उसमें मैंने बियर लैम्बर्ट्स लॉ एक्सप्लेन किया है. So you can just go and watch that video. that उसका लिंक मैं दूंगी मैं. ये लिंक है उस एक्सपेरिमेंट का on the virtual lab. So if you find it interesting, you are also highly encouraged to perform these experiments on the virtual lab. All right. Now we are at the end of the session, जहाँ पे मैं सिर्फ आपको कुछ information बताऊंगी for your knowledge. Okay. Now what we used to get. Now you just have this 1 hour lecture, right? But what we used to do when we were in graduation and MSc as a chemistry student, our teachers used to give us some data कि एक so and so XYZ molecule है, उसका रोटेशनल स्पेक्ट्रोस्कोपी का ये डेटा आया, उसका आईआर का ये डेटा आया, एनएमआर का लेट्स से ये डेटा आया, and now tell me what is this molecule. So they used to give us the graphs, the spectrums, and they used to ask us to find out what is this molecule. ओके, तो हमें क्या करना होता था, आपको मैं बताती हूँ। जैसे कि फॉर एग्जांपल आईआर स्पेक्ट्रोस्कोपी का ये स्पेक्ट्रम है। आईआर में अगर क्या यूनिक चीज है, आईआर स्पेक्ट्रम बेसिकली टेल्स अस व्हाट काइंड ऑफ फंक्शनल ग्रुप इज प्रेजेंट इन द मॉलिक्यूल. So you can come to know, okay, fine. So peak at this point represents, oh, there's a ketone in the molecule. Okay. Peak at this particular point represents there is an OH group, an alcohol is there. तो वैसे you have to deduce. So ये जो सारा record है, there is a literature available कि इस peak पे, इस point पे अगर peak आया, तो this is the functional group. दूसरे point पे आया, so this is the functional group. So these values, I right now I do not remember anything. But when I was a student, we don't used to purposely by heart, but इतना practice करते थे कि वो by heart हो जाता था. So इतना वो याद था हमें. And then let's say for example, NMR spectroscopy. NMR spectroscopy tells you how many different kinds of hydrogens are there. So we used to deduce कि okay, so there are 5 different kinds of hydrogen. So this is the possible structure. That is a possible structure. वैसे, okay, and then we used to finally tell the teacher, okay ma'am, this is the molecule that is there. And then वैसे हमें मार्क्स मिलते थे वो सब. तो वो थ्योरी में होता था, like when they used to teach us this concept in the theory lectures, these kind of problems we used to get, numerical problems on the problems, the questions. But in real life, in practical life, how did I implement spectroscopy? I would like to tell you, I was working on synthesis of ionic liquids, green solvents. If you remember, while teaching green chemistry, green solvents में मैंने ionic liquids का example बताया था. तो my project synthesizing ionic liquids using various possible procedures, and then just because मैं बोल रही हूँ कि हाँ ionic liquid मैंने बनाया है, तो इससे हमारे प्रोजेक्ट गाइड्स खुश नहीं होते थे. Whenever we used to have our presentations, they used to ask us for the proofs. कि what is the guarantee that this chemical that you have synthesized is an ionic liquid? So I used to synthesize, and whatever is the product that I used to get, I used to carry out. I obviously we had all the spectroscopes. I have completed it from Pune University, right? The actual campus. It has all the high-end spectrophotometers. So I used to carry out all the spectroscopies, and then I used to show, okay, sir, this is the spectrum that I got, and it shows that this product is formed. Only then they used to trust us. तो ऐसे नहीं था कि केमिकल बनाया, ए लिया, बी लिया, ऐड किया, सी बन गया, कंपाउंड बन गया. No, whatever you carry out, you need to back that product with the help of some support or proof. That is how I implemented spectroscopy in the practical life. Okay. So that's it. At the end, I have added certain questions, but also the questions in the sample paper you can refer and prepare yourself for the exam accordingly. Okay. So that's it. I'm done teaching this chapter. Now, this is the last lecture. I feel extremely sad that in the last lecture, I did not get chance to conclude the semester because that I do in every time, but I could not conclude the semester. In this entire semester, the time actually provided, and the time that we got was very less actually. Like we used to conduct a lot of activities. Even in online, we conducted so many activities. तो बट जो भी पढ़ाया वो बेसिकली एक्टिविटी बेस्ड ही था. देयर यूज्ड टू बी डिस्कशंस इन द क्लास, यू पीपल यूज्ड टू आंसर. आई डू नॉट recall any session जहाँ पे बच्चे शांत थे. Everybody in both the divisions, students used to answer. Okay, so that is it. It was a very good experience teaching both the EXCC divisions. You all were very supportive, very kind, and very patient students. I just wish all the very best to all of you, to each and every one of you. I pray to God that all are blessed with good health, and I wish good, prosperous futures to everybody. And just one request that just please be in touch with all your teachers. It feels extremely good that the students are in touch with the first year teachers. And yes, that's it. Thank you so much. Good luck, everybody. Take care and see you all soon. Prepare well for exam, huh? Good luck for the exam. Chalo, bye bye. Take care.